Last section, guys. So we're looking at inverse trig functions. So find the value of the inverse trig function. When we look at inverses of just a regular function, our x and y switch. When we look at inverse of a trig function, our angles and our points that switch. So when we have an inverse, 0 is the point, and our answer will always be the angle. So we want the angle when the point is at 0. So cotangent, we need to remember is the reciprocal of tangent. So tangent is y over x, or sine over cosine. And cotangent is x over y, cosine over sine. So this is a fraction, but our value is 0. So in order to get a fraction to be 0, the numerator has to be 0 and the denominator can be any number. Doesn't matter what it is. As long as the numerator is 0, the denominator is whatever. You cannot have a 0 on the denominator, and we're going to look later where we see some restrictions in our domain because the denominator becomes 0. So right now we need our cosine value to equal 0, and at that point we're going to get the angle value. So one of these angles, cosine, is 0. So I'm going to open up my other tab with the unit circle. So here's our unit circle. We're looking for an x value of 0 in our points. So right here, x is 0, y is 1. At x equals 0, the angle is pi halves. Or negative pi halves. So this is negative pi halves because if we look at our, here now I'm in your 4.4 notes, when you look at the domain of your trig functions, here's cosine, sine, tangent, secant, here's cotangent. So our domain cannot be certain values and we have these asymptotes. So when we're looking at the unit circle and we're looking at tangent and cotangent, the domain is actually just this part of the circle. And this would be 0. This would be positive pi halves and negative pi halves for tangent. But because it's the reciprocal when we're looking at cotangent, then it's the other way. Right? Things switch. So pi halves, negative pi halves. Alright, so which trig function has a range of 0 to pi? And at this point, you just need to go look at your notes. So we're looking at arctangent. So remember, arc means inverse. It's the same as saying it like that. These are exactly the same. Inverse secant, inverse cotangent, inverse cosecant, inverse cosine, inverse sine. You can say arc or inverse, either way, but those mean the same thing. So we want to know which inverse function has a range from 0 to pi. And again, if you go look in your notes, those are all in here. Here's our regular functions, our inverse ones. I'm looking at range, 0 to pi. Inverse. Aha! 0 to pi. Inverse cosine. Oh, that one's 0 to pi, but it's not included in the cotangent. This one is included. So, inverse cosine. Same thing, this one is asking which one has 0 to pi not included. That's the one we just looked at, right? So no lines under the inequalities is the cotangent. Find the value of the inverse trig function. So last time we went to the unit circle and we looked. I just want you to know that sometimes you're welcome to just use Desmos. So this tells me 90 degrees. If I go to radians, it's a decimal because of pi. So if I want cosine of 90 degrees, I'll go to my unit circle. And it is, here's 90. 0, see? So we're at pi halves. But again, because we're looking at the restricted domain in this, it's going to be negative pi halves. Okay, find the value of the inverse trig function of sine. Notice that that square root of 2 is on the denominator, so I'm going to hurry up and rationalize it so it looks like our unit circle. So now I have negative square root of 2 over 2 over 2. Now we can go to our unit circle, and again, if you put it in Desmos, you're going to get negative 45 degrees. Or you can go to the unit circle and come down here. It's actually going down 45 degrees because this one has so much domain in it. When we look at domain of sine, we go up pi halves, down pi halves. So this would be negative 45 degrees because we're going down 45 degrees. So that would actually be negative pi force because this is positive pi force. Okay, find the value of the inverse trig function of cosine. Sorry about that. Okay, so that is equal to 150 degrees, right? Or I can go to my unit circle. 150 lines up with negative square root of 3 over 2 in the y or in the x spot. So 5 pi 6. Okay, inverse trig function of tangent. Negative square root of 3, so negative 60 degrees. So 60 degrees is pi thirds. So negative 60 would be negative pi thirds. Okay, so this is saying go look at our range of our inverse trig. So I'm going to go back. And now I'm going back to the 4.4. And I want my range to be negative pi halves to pi halves with the line underneath on the inequality. So negative pi halves to pi halves. Oh, cosecant. Am I already there? Not included. Yeah, that was... Or inverse sine. So let's see. I think they both do. So I bet it's a select. I bet it's y. Let's just go double check. Negative pi halves to pi halves inverse sine. And then, oh, cosecant. Y cannot include 0, so it's not that one. It's just inverse sine. Or arc sine, right? Okay. So inverse trig function, arc cosecant of negative 2. So this is good. Notice that I only have sine, cosine, tangent here in my functions. So if I want the inverse of the other trig functions, I have to go to graphing, and they're right here. So I have inverse cosecant of -2, and if I go here to settings, I'm in radians, I'm going to go to degrees. So -30 degrees. So 30 degrees is pi 6. -30 would be pi 6. Okay, which one has a domain of negative pi halves? I forgot the pi halves. I'm looking at not inverse, just trig functions. So that got me earlier. I'm going to go to just the trig functions. Domain is pi halves. So tangent would be my answer on that one. So my suggestion on this one would be to have the notes open. The unit circle notes, the 4.4 notes, and then put things in the calculator and see if that helps. Good luck.